I'm a structural engineer, but I didn't want to get too technical, and it's getting very late, so I'll keep this very short. I just wanted to touch on some kind of really high-level concepts to think about when we're building buildings, and a little bit on what we've learned from the last, reflecting on the last year. And I guess in relation to foundations, when we think about the damage caused by the earthquake, foundation movement through liquefaction or lateral spreading hasn't actually been directly applicable to any of the deaths, which is quite important when we think of it. This is an issue that we need to think about. This is conserving our community, it's conserving our buildings, and so life safety is paramount. But there's also there's some alternative approaches, some more innovative approaches that we can think about when what do we do with our buildings after the earthquake. So just going to touch on a couple of concepts around that now. Keep it symmetrical stupid is the new acronym for KISS instead of keep it simple stupid. Imagine this is a cross section through your building with the ground here. I mean, I've seen a few buildings in Christchurch that like to hang out over their garages and that sort of thing. A lot of people didn't usually put foundations under that bit, they put strong ones here. We know we've got softer ground. Just spreading your foundation and keeping it under the middle of the building is a sort of primary thought that, it seems obvious at this level, but we haven't always followed that through in our engineering. We don't just need to think about this bit, we need to think about what this bit is, what's under the ground. And so maybe under the ground, the ground is unsymmetrical. So rather than just building a big building that covers a whole lot of different grounds, maybe we should, areas of the ground, maybe we should be splitting this building up into different parts that can move differently. Or maybe even taking that to a higher level, which you've done somewhat in your city plan, but maybe more specifically about what kind of buildings go where on what types of soil. Just thinking about your average box of building with a bunch of little piles. So even if those piles were driven shallowly, so maybe they did settle a bit during liquefaction, just by doing little things where, if we cast some steel threads into here and left holes in above every pile, you could come back after an earthquake and you could put a beam across here and a hydraulic jack in and push the building up relative to the piles. This is the sort of stuff that doesn't cost anything when you build a building. It's just that we don't really think about that now. But if we design buildings to be maintained, I think the question about 50 years before was really relevant. We need to be designing our buildings that we maintain them, we keep them up, and part of that is actually a seismic maintenance, that we're putting money aside so that we can repair our building over its lifetime to extend that to 100, 150 years. This is a bit of a funny sketch, but the idea is the plan of a building. Over history, most buildings have been two-wall buildings. Like you look at the old Georgian buildings in Europe, two brick party walls and a floor in between. That's a classic way of most of the buildings around the world. And you look at what I think of Christchurch as two precast walls and a big steel rafter over the top is a lot of the sort of bulk shed type architecture that it's also in Christchurch. And really, when I reflected on building in this area, maybe we need to think about what we do about these walls a bit more, because at the moment we try and make them as light as possible to keep the fire from going over to our neighbours. Maybe we should be getting these to do a bit more for us. So my first thought was, if all of these piles perform differently after an earthquake, well actually maybe if we've got a big steep wall that's structurally held together and very rigid, well the building doesn't really mind because it can share, even if a third of the piles fail, like the whole building's not going to tilt, and so you've got some load sharing along those walls. If you take that to the next level, maybe the wall only needs two big piles, so rather than spend lots of money putting little ones in, we can afford to put in just a few piles on a very large building. Or, pardon my very rough sketch, but the idea is to represent some sort of three-dimensionally braced form building. Rather than doing all our strength down here, maybe you can make a very rigid box up above, even though braced in some way that leaves it transparent, that you can then look at a lighter pile, but knowing that your building will always settle evenly because you've created this rigid box. And we don't really think about this in the way we design our buildings, that interaction between ground, engineering and architecture. This is taking that a step further. This is one that came when we were brainstorming in our firm one Friday, was that why don't we, the whole modernist idea of public space should be at the ground floor of every building and the building's suspended above that. Well, shouldn't the foundation of the building extend to above the ground floor? Rather than do all our hard work repairing damage and settlement down here, why aren't we repairing damage and settlement at the tops of these foundations where we can see it, where we can access it, and have these changeable bits of the building that aren't buried in the dirt and the water? And lastly, we've been involved with quite a few prefabricated buildings, and really after, we're walking around those first couple of days after February, what really struck me is how well our modern facades have done. These glass facade buildings, they made in what they call a unitized way. So they make each piece of glass has a bit of frame around them, and then you put all those frames together. Now you don't just need to have glass in those frames. They can have terracotta panels, they can have all sorts of different materials in those frames. But what's beautiful about those frames is the highly manufactured, highly engineered joints between them, and they're very accurately made. So you can assemble buildings out of components, but they can be designed to slide together so that even if your structure's repairable after the earthquake, your facades need to be repairable. The bits of your building need to be repairable. So if we're thinking more about component-based buildings with designed edges, they can be more flexible for the kind of movements we're talking about.
Can I just bring up one question? The gentleman at the back mentioned a bridge. I actually saw that television programme. This particular base for the bridge, it had sort of the guy off Top Gear actually was involved with the same thing, and he was featured standing in a box filled with granular material, and it held, but it allowed the movement. And I'm surprised this hasn't been discussed anywhere. I haven't seen it discussed, but it certainly worked on that bridge. It was absolutely amazing. They didn't link the columns on the bridge at all. The columns sat a metre above that base, so it was completely separate. Now, I haven't seen that mentioned at all anywhere since we've had these quakes.
Well, the steel guy sort of alluded to it. You can do different forms, different depths of ground improvement. You can use a big, deep wodge of gravel to work like a concrete raft. Concrete's just very highly engineered gravel, just glued together with lots of cement. So you can make this big mat of gravel and sitting it on a series of piles to then sit your columns on. So it's just different. It's just a deeper, lower tech material to do the same sort of thing.
So it'd be cheaper?
Potentially, and certainly some of the remediation works that's done is around lots of little driven piles that help pin the soil together and relieve liquefaction. So yeah, there's some work done. TNT have Tockman Taylor have done a lot of work around that sort of stuff. Okay.